Alright architects, welcome to our final episode. This is the moment where the blueprint meets the real world, the physical architecture layer. If conceptual was the dream and logical was the plan, physical architecture is the trip to Home Depot. Physical architecture is where everything really becomes real. This is the level where your carefully crafted logical components stop floating in theoretical space and start becoming actual machines, platforms, databases, services, and cloud resources.
Alright, now that we've covered conceptual and logical architecture, this is where everything becomes real. This is the physical architecture layer, also called the technician's view. It answers one simple question: where does this live and what runs it? Starting at the top, we have the internet. This is how users, systems, and devices connect into the enterprise. Traffic flows into our web servers, which acts as the front door for applications and services. These web servers host the software and applications, things like WordPress, Webflow, custom apps, and payment systems like Stripe or PayPal. This is where user requests are handled before anything touches core data. From there, requests move to database servers, where structured and unstructured data lives. This includes SQL databases, NoSQL systems, and enterprise data stores that power the business. All of this runs somewhere, in a data center or cloud environment like AWS, Azure, or GCP, Google Cloud Platform. This layer defines compute, storage, networking, and availability, the physical foundation. On the other side, we have hardware and devices, kiosks, registers, robots, mobile devices. They generate telemetry data, feeding real-world signals back into the system. So, physical architecture is about making logical decisions executable. It's not theory. It's cables, servers, regions, and environments. This is where architecture meets reality.
When you hit this layer, you're no longer talking about data storage component. You're deciding whether it's Postgres, Google's BigQuery, AWS DynamoDB, or something you're definitely not paying enough for. A logical integration suddenly turns into an API gateway, a message queue, or a direct VPC peer connection. And that compute from the logical world? Yeah, now it's a Kubernetes cluster, a server function, or a VM with a surprisingly long name your DevOps engineer swears is meaningful. This is also where constraints show up, budgets show up, security show up with a clipboard, networking shows up 5 minutes late but somehow still has veto power. Architecture forces you to reconcile the clean elegance of your logical design with the messy realities of actual infrastructure. You're making decisions about availability zones, network segmentation, load balancing, encryption, deployment patterns, logging, and monitoring. All the things that keep the business running at 2 a.m. when no one wants to be awake. It's also the layer some teams may feel most attached to because it's tangible. It's infrastructure you can deploy, services you can scale, environments you can break accidentally but recover from gracefully. Hopefully.
To design physical architecture at scale, architects rely on specialized tools. ER Studio is widely used for data modeling, especially at the physical level. It helps architects define how databases are structured, deployed, and governed. Plainview focuses on enterprise planning and portfolio management. At the physical layer, it helps align infrastructure investments with delivery times and capacity. And then there's LucidScale. LucidScale is powerful for cloud visualization. It automatically maps AWS, Azure, and GCP environments, showing real infrastructure, not assumptions. And then there's Orbis. Orbis software supports full enterprise architecture modeling, including physical deployments. It connects strategy, systems, and infrastructure into a single architectural view. And Plant UML? For engineers who prefer code, Plant UML allows architects to diagram infrastructure as text. It's fast, version controlled, and works well in technical teams. And finally, Microsoft Visio, still a staple for physical diagrams, layouts, and documentation. Different tools serve different needs, but the goal is the same: clear, executable physical architecture that teams can build and operate.
In the segment framework, this is the physical world, where abstractions harden into components and components harden into technology. And once you're here, every decision has weight. Cost, performance, compliance, operability. It's the final transformation of business intent into something that can actually run in production without becoming the support group's weekly topic. And that's a wrap on entArch. You now understand the full architecture stack, the conceptual, what and why, the logical, the how, as well as the physical, with what and where. Whether you're modernizing a platform, designing a new product, or trying to untangle legacy chaos, these 3 layers give you the blueprint you need. I'm Raheem Kareem, this is entArch, and I'll catch you in the next series.